Hello, am I audible? Anyone please confirm whether am I audible or not?
Hello. Good
Yeah.
evening, ma'am.
Am I
Am I
audible?
audible? Yes, ma'am.
Okay, thank you. Good evening everyone. I am Riya Tapwal. I am doing PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur. Today we will discuss the topics of week 10 and after that we will discuss the assignment questions of same week. So first of all we will discuss about smart cities and smart homes. So what exactly is smart city? So basically smart city is an urban system which consists of various buildings, industries, hospitals, schools that uses information and communication technology in order to make the infrastructure more interactive and accessible. So basically what is the need of smart cities? So, so the first point is rapidly growing urban population. So, with time, the population is growing very fast, and in order to make the population interactive and provide various services to the population, it is required to have. There is a need of smart cities. Further, since the population is increasing, due to which our natural resources are depleting very fast, so there is a need to utilize these resources properly. So basically if we have smart cities, we can utilize those resources in an optimized manner. So for preventing your fast depleting natural resources, smart cities are required. Then next is changes in environment and climate. So with time, as it is clear that the temperature is continuously increasing, our glaciers are melting, and the weather is changing with time. So there is a need to prevent our environment. Okay, so in order to check the changes in the environment and in order to prevent our environment from pollution, there is a need of smart cities. So basically in this table, the analogy is created between humans and smart cities. So here basically, for example, in humans there is skeleton, skin, organs, brain, nerves, sensory organ, cognition. Similar to this only, in smart cities there are buildings and industries. For example, skeleton in human body is similar to the buildings and industries and people in your smart cities. Now the skin is connecting the different parts of our bodies. Similarly, in case of your in case of your smart city, transportation is responsible for connecting different parts. Then the organs. In case of human, there are various organs. So similarly for smart cities, your hospitals, schools, banks, police station, these are the organs of smart city. Then the brain. So in case of your smart cities, the embedded intelligence, that is using machine learning or artificial intelligence, is the brain of your smart cities. Then the nerves. So nerves is responsible for the communication part in a human body. So similarly, in case of your smart cities, telecommunication networks are responsible for the communication. Then the sensory organs, for sensing different things. There are various sensory organs in human body. So in case of your smart cities, various sensors are used for the same purpose. Then the cognition. So as cognition is there, then there is software in case of your smart cities. Now the applications of smart cities and smart homes. So first one is your smart economy. So basically, with the change in time, or with the evolution in technology, there is a need of smart economy. So basically, there should be development in technologies. There should be advancement in your entrepreneurial advancements. There should be also there. So all these things consist of your smart economy. Then next one is your smart governance. So in case of your smart governance, there should be participation of citizens also. There should be transparency between the government and the citizens. So that will make smart governance. The next is your smart people. So the people who are using various kinds of things in order to sense the environment, in order to sense the environment, or in order to make different in order to do different things, smart peoples are there. Then smart mobility consists of your transport and ICT. Then smart environment. So in case of your smart environment, different methods are taken in order to prevent the natural resources from depleting, and in order to optimize these natural resources. Then smart living. So smart living means to optimize or to improve the quality of life. Now first, this first diagram is these diagrams are showing your smart economy, governance and smart people. So first diagram is of your smart economy. So these are the various components of smart economy. The main three components are startups, founders and indigenous diaspora. So basically these three components are interacting with other components such as your venture capital, academia, portal, public sector buyers, worldwide buyers, government agencies, global MNCs, international diaspora, in order to make your economy smarter. The next is your smart governance. So similar to your smart economy, there are three main components in your smart economy. There are three components in your smart governance also, that is your government agencies, then officials and citizens. So basically these three components are interacting with other components. For example, your finance, banking, reforms, safety, surveillance, management, public services and emergency services, in order to make the governance transparent between the citizens and the government officials. Next one is your smart people. So basically the three main components are education, healthcare and population. and these three components are interacting with other components in order to make smart people. Now smart mobility. So here also there are three main component, that is your locality, cities and population. These are interacting with other components in order to make the mobility more smarter. So basically in case of your smart mobility, the other components are those components which are responsible for moving moving the person from one place to another place, or moving the one object from one place to other place. Next is your smart environment. So the three main components are localities, contingencies and population, and these three are interacting with other components in order to make the environment more smarter. So basically in order to detect the disasters, in order to monitor the pollution, to monitor the forest, in order to increase the agriculture, and in order to manage the waste material. So in order to make these facilities, these three main components are interacting with other components. Then smart living. So in case of your smart living, localities, population and servicing agencies are the main three components which are interacting with the other components in order to make the living smart and improve the quality of life of the people. Now the current focus area of smart cities are, first is your smart homes. So basically smart homes consist of various equipments which are embedded in your homes in order to make those homes smarter. For first one can be your health monitoring. So in homes, different people are using different kinds of devices which are responsible for monitoring their health, and after that these devices take the data of the person and send it to the doctors who are sitting at the remote place, and these doctors can monitor the patient from their remote locations only. So just by sending the data through your smart devices, the doctor can monitor the patients remotely also. Next is your conservation of resources. So basically in smart homes, different equipments are embedded. For example, your smart bulbs, smart AC. So these devices turn on whenever a person enters into the room and turns off whenever the person left the room. So basically this leads to the conservation of resources, because sometimes if person forgets to turn off the light, then it can results in the wastage of energy, right? So if you are using smart appliances, then it will prevent the energy also. Further, security and safety will be more. The another example of smart homes is the quality of life get also increased, because in smart homes, according to, for example, if you have smart AC, then according to the temperature it automatically sets the temperature of the room. Similar is the case with your smart lights also. So based on the light which your room is getting from the outside, from the sun, the smart bulb can adjust its light intensity accordingly. The one more example is there are some bulbs which can adjust their intensity according to the mood of the person. So these are the different examples of appliances which can be used in your homes in order to make the home smarter. Next one is your smart parking lots. So basically in smart parking lots, in order to provide auto routing of vehicles to the empty slots, so basically when wherever is the empty parking slots, the smart parking lots will route your vehicle to that particular slot. So this will also results in the conservation of your fuel. Next is your auto charging for services provided. So basically for the amount of time your vehicle is parked in the parking lot, for that particular of time, for that particular amount of time only the person have to pay. And the next is your detection of vacant slots in the parking lot. So this I have already told you. So with the help of this smart parking lots, we can detect the vacant slots. So basically for this what you have to do is you just have to put cameras in your parking lots. Those cameras will capture the pictures of your parking lots, and by performing the image processing you can get to know that where exactly is the vacant slot. So further on detecting the vacant slot, you can guide the vehicle to that particular parking lot. Next is your smart vehicle. So smart vehicle are responsible. Smart vehicle can assist drivers during the bad weather or low visibility. It can also detect the bad driving patterns or driving under the influence of substances. Then it also generate auto alert generation during the crashes. Next one is your smart health. So smart health is the same thing which I have discussed during your health monitoring in your smart home. This is one of the method. And also in case of your smart health, various equipments are used in hospitals which automatically generates alarms to the doctor, and whenever a particular patient is suffering from a particular kind of disease, for example if he is feeling breathlessness or if he is getting heart attack, then automatically the alert is generated at the doctor's end. So next is your pollution and calamity monitoring. So for this you can use various kinds of sensors in order to detect the pollution. For example your gas sensor. So gas sensors can detect the level of your carbon dioxide, nitrogen oxide, ozone. So different kind of gases can be detected, and on the basis of the level of these gases we can detect the pollution. Further in order to detect or determine the calamity, various vibration sensors can be used. So these vibration sensors can check the seismic motions of the plates, and with the help of those we can detect whether there is a possibility of any calamity or not. So this can be done with the help of this can be done in your smart cities. Then next is your smart energy. Smart energy means various smart metering systems are put into your smart cities, and these smart meters will charge you for the amount of time you are going to use a particular service. Then the smart agriculture. So first one is your automatic detection of plant water stress. So with the help of smart agriculture you can detect whether the crops are getting proper amount of water or not, whether they are getting proper amount of nutrition or not, You can also detect if some intruders are trying to intrude into your agricultural fields or not. So all these things can be done with the help of smart agriculture. You can also automatically put fertilizers or water after regular interval of time with the help of smart agriculture. So basically for that you have to place or deploy different kinds of sensors into your agriculture field. For example, in order to detect whether your crops are getting proper amount of nutrition or not, so you can place some gas sensor there, so it will detect the amount of nutrition in your crops. And you can also place humidity sensor, it will detect the water level, and further if the water level is less than the threshold value, it automatically starts the actuators which can spray some kind of fertilizers or weed removal things also. Now the technological focus areas. So first one is your data collection. So we also need to, first of all we need to collect the data from your smart cities. Then the second one is your data transmission, then using different network topologies, network protocols, you have to transmit the data from your sensors to the data storage place or to the cloud. Then after that on that particular data you have to do some processing. First of all you have to clean the data, you have to remove the vague value from that, and after doing that you have to do some analysis, and on the basis of that analysis prediction can be made or some comparison can be made, and after that some actions are taken accordingly. Now the challenges that are faced in smart cities. So first one is your security and privacy. So the data which is collected with the help of sensors in smart cities are exposed to attack, various kinds of attacks. Then there are various vulnerabilities also. Then multi-tenancy also includes the risk of your data leakage. Then next is your heterogeneity. Since we are getting data from different kinds of devices, so it is difficult to manage that much amount of devices, and further to store that much amount of data and perform processing on that much amount of data. Then reliability. So unreliable communication is there due to the vehicle movement, or sometime your device will also get fail, due to which we are not able to get the complete data. Then next is your large scale. So since large amount or massive amount of sensors are deployed, and these sensors or these devices are mobile, so due to which it become difficult to manage that much amount of devices and get data from that much amount of devices. Next is your legal and social aspects. So services which are based on user provided information may be subject to local and international laws. So you cannot get the personal data from anywhere, so you have to take consent, and that should may be subject to local or international laws. Then individuals and informed consent are required for using the human data as a data source. Then big data. So the data which you are collecting is massive, so in order to transfer, store and maintain that much huge amount of data is expensive. Data cleaning and purification is time consuming process, and analytics on this much amount of data is processing intensive. Then the sensor networks. So the choice of appropriate sensor for individual sensing task is crucial. So which sensor is most suitable? So for example, in order to detect the obstacle, you can use different kinds of sensor. For example, your ultrasonic sensor, you can use camera also, you can use lidar also. So which sensor is most suitable in that particular application is and the decision is crucial in order to decide which sensor is most suitable. Then next is energy planning is crucial. Then device placement and network architecture is important for reliable end-to-end IoT implementation. Then communication medium and means plays an important role in seamless function of IoT in smart cities. Now next topic is your data fusion. So basically we are getting data from different kinds of devices, from heterogeneous devices, and the decisions which we are making is not based on the data which we are getting from single sensor. So the decision is collectively based on the data which we are getting from all the devices. So for that purpose we have to fuse the data, we have to aggregate the data. So enormous volume of data is produced periodically in smart city environment. So various challenges include making data available, incoming large data volume precise and accurate. So the quality of data precision and accuracy affect the quality of decision making in IoT enabled smart cities. So basically the data which you are getting, the accuracy of that data is most important factor in order to make in the decision. So data fusion enables optimum utilization of massive data gathered from multiple sources and across multiple platforms. So basically if you are using single sensor, right, and if that sensor is faulty, so the decision which is generated is not accurate. So if you are using single sensor only, so then the decision which is generated is not efficient in that case. But at the other end, if you are using multiple sensors at the same time, then the decision which is generated, if one particular sensor is somehow faulty, then the data which is generated by other sensors, by fusing the data from all the sensors, we can consider the data of that faulty sensor as an outlier and neglect that data. And by fusing the data from other sensor, we can generate more efficient decision as compared to the previous case. Next is your multi-sensor data fusion. So it combines the information from multiple sensor sources. It enhances the ability of decision making system to include a multitude of variables prior to arriving at the decision. Inferences drawn from multiple sensor type data is qualitative superior to single sensor type data. So this thing I have already explained. Information fusion generated from multiple heterogeneous sensors provides for better understanding of operational surrounding. So basically whenever you are using heterogeneous sensors or multiple sensors, then it will provide better understandings of the surrounding. Next is challenges. So if you are fusing data or if you are aggregating data, then what are the challenges that we can face? So first one is your imperfection. So sometimes inaccurate or uncertain data can be gathered. Next is your ambiguity. So ambiguity is the case when there are some outliers and missing data. Then conflicts. So if same sensor type, if you are using two sensors, okay, and both the sensors are producing different data at the same location, then there might be some conflicts also. Then next is your alignment. So if you are using data from different sensor, then there is a need to align the data into a singular frame. Next is your trivial features. So processing of trivial features may bring down the accuracy of the whole system. Now, data fusion opportunities in IoT. So first is your collective data is rich in information and generate better intelligence as compared to data from the single sources. The first opportunity is optimal amalgamation of data. So how to aggregate the data most optimally. So this can be the opportunity where different works can be done. Then next opportunity may be enhancing the collective information content obtained from multiple low power and low precision sensors. So basically you are using low power and low precision sensor. The aim of the problem is to generate more efficient information or more efficient decision from these kind of sensor. The next is your enables hiding of critical data sources and semantics. So and this is also one of the opportunities. Now the stages of data fusion. So data fusion can be done at different stages. First one is your decision level. So it means the ensemble of decisions. So basically you have collected data from different sensors and you have generated decisions for each of the sensor separately, and further the decisions are fused together. Next one is your feature level. Feature level means just before taking the decision you are going to fuse the data or you are going to aggregate the data. Next is your pixel level. So pixel level means the fusion of data at the imaging device. So basically this is for the imaging device only. So imaging devices means the cameras you can consider. So basically in case of your pixel level data fusion, what happened is different images are captured by different cameras of a same place, and the most important information of each image is taken, and based on, and these informations are collectively aggregated together in order to take the decision. Next is your signal level. So in case of your signal level, the data fusion is done within the local network. Now the mathematical methods of data fusion. So there are various mathematical methods that can be used. So first one is your probability based. Inside your probability based there are various other methods such as your Bayesian analysis, statistics, recursive methods. Next is your AI based. So ANN can be used, artificial neural networks, machine learning, convolution neural networks can be used. Theory of evidence based. So in this belief function, transferable belief models can be used. So I have given one link here which will provide you the detailed study of all these methods. So if you want to go if you want to get more idea about these methods, you can go through this link. Now AI in IoT decision making. So consider in case where you are not using AI, you are not using any kind of intelligence. So in that case the decision which is taken is not that much efficient. However, if you are using some artificial intelligence in decision making, then the decision which is taken is more efficient, because if first time whenever your model is trained, it will generate some decision, and if that decision is not up to the mark, some feedback is given to the model, it will again train. So basically if AI is there, then there is high accuracy in decision making. Now this is the case, this is example of data fusion. So basically here on this car different kind of sensors are used. For example, your ultrasonic sensor, lidar, RGB camera, in order to detect the obstructions. And further, on the basis of the data which is collected by these three sensors, the obstructions are detected, and further that information is sent to the server or to the satellite in order to make some processing. Now, smart parking. So, smart parking is responsible for shortening the parking search time of drivers, because it will let you know the vacant lots in your parking lots, and then it reduces the traffic congestion. Also, it reduces pollution by keeping unnecessary lingering vehicles off the roads. Then it reduces fuel consumption and cost, increasing urban mobility, and shorter the parking search time results in more park time and hence more revenue. Yeah, you have a question. Someone has raised hand. Dr. Ravinder Kumar, do you have any question? Hello, am I audible?
Yeah, it's audible, ma'am.
Okay. Okay. So, in case of your smart parking, there are three different functional layers. First one is your information collection, second is your system deployment, and third one is your service dissemination. So, information collection consists of various kinds of sensors, parking meters, sensor networks, crowd sensing. So basically, these components are responsible for collecting the information about the environment or about the parking lots. The next one is your system deployment. So it consists of various components such as your software system, information management, e-parking, guidance, and data analytics. Next is your service dissemination. So this component is responsible for providing various services such as your dynamic pricing strategies, infrastructure based information, infrastructure free information, parking choice, vehicular activities. So all those services are provided by your service dissemination. Now the information sensing can be stationary as well as mobile. So in case of your stationary, large number of sensors are there, and it can detect the presence or absence in a particular place. However, in case of your mobile sensing, fewer number of sensors are required, and it can collect the information along the route. Since the sensors are moving, so it is not necessary that it can only detect the environment, or it can only sense the environment of a particular place. So it can get the information along through the routes. Next is your energy management in smart cities. So in energy management, energy efficient solution should be the protocols that are used should be lightweight. There should be optimal scheduling of resources. Predictive model should be used in your energy management, so that energy consumption should be less. Cloud based approach should be used, low power transceiver should be used, and cognitive management framework should be there. Then ambient energy harvesting system include your RF sources, wind, sun, heat, vibration. So all these are under your ambient energy harvesting system. Now So basically the amount of energy that is harvested will depend upon the sensitivity of your harvesting circuit, the distance between the device and source, because some energy is required in order to transmit or disseminate the information, and it will also depend upon the environment where you are deploying your sensors. The next topic is your smart home. So smart home infrastructure consists of intelligent network devices infrastructure which are seamless integration of various devices using wired and wireless technologies. So basically smart homes allows easy use of household system which creates a highly personalized and safe home space. So there is a corporation which indulge there is a corporation of various home systems such as your GE, Cisco, Google, Microsoft and various others. So it provides productive and cost efficient environment which maximizes the effectiveness of occupants, and it also provides efficient management with minimum lifetime cost of hardware and facilities. Now it optimizes structure, system, services and management and interrelationships between the above three. So basically the aspects of smart home consist of communication network infrastructure, intelligent control and management, sensor networks, smart features and automatic responses. Now the elements of now in smart home in home area networks we will discuss about elements, standards, architectures and initiatives that are taken. So the network so what does this home area networks means? So the network contained within a home is called your home area network. So see, in case of your personal area network, all the gadgets that belong to a person that is your personal area network. In case of your LAN, the devices which are connected over a building or within a particular area, within a restricted area, that is your LAN, that is your local area network. However, similar to these two kind of network, the network which is available or contained within a home, that is your home area network. So it enables remote access and control of devices and systems and provide amalgamation of various systems within a home such as your security system, home automation system, personal media and communication. Now the elements of home area network. So it consists of three main elements, that is your internet protocol, wired home area network and wireless home area network. So first one is your internet protocol. So multi-protocol gateway bridges the non-IP network to the IP network. The bridging between the new technologies is limited in this case. So for new technologies or network, a new mapping is required for bridging to perform satisfactorily. Next is your wired home area network. So in wired home area network, easy integration with pre-existing home infrastructure is there. It is of low cost and can use power line, coaxial cables, telephone lines, optical fibers and other such technologies for communication between your different home appliances. Next is your wireless home area network. It can use Wi-Fi, Zigbee or other standards such as your low band in order to make the communication possible between your different different home appliances. The implementation of wireless HAN is more easy as compared to wired. Now it is showing the same thing, that your home area communication and networking can be of wired or wireless type. In case of your wired, electrical lines, telephone lines and optical fibers are used in order to make the communication possible between your different home appliances. And in case of your wireless, uh, battery operated or battery free communication medium can be used. For example, for battery operated, Z-Wave, Wi-Fi, 6LoWPAN, Zigbee are the example. However, for battery free, an ocean is an example which is using the energy from the environment in order to operate or in order to make the communication possible. Next is your home area network standards. So basically these are different standards. First one is your UPnP, DLNA, Connex, LonWorks, Zigbee, Extend. So these are different standards which are used in home area network. So first one is your universal plug and play, which is UPnP. So it is an application layer technology which is mainly web based. TCP/IP protocol stacks provide support for lower layers and enable seamless integration of various technologies. So basically this is based on TCP/IP protocol. It provides transparent networking with support for zero configuration networking and automatic discovery of services. Next is your DLNA, that is Digital Living Network Alliance. So it is a trade organization which is created by Sony, Intel and Microsoft. It connects cable based network with wireless networks for increased sharing of media, control and access. Then it domestically shares network media resources. So basically DLNA is for connecting your wireless networks with your cable based networks. Next is your Connex, that is your is KNX also. It is an open important standard for home and building networks. It utilizes full range of home communication infrastructure, for example your power lines, coaxial cable, twisted pair, radio frequency, in order to make the communication possible between different appliances, and it must be set up and configured by software before its proper usage. So in this case, see, in case of your UPnP there is no need of any configuration. However, in case of your Connex, it must be configured. Next is your local operation networks, that is your LonWorks. So every device includes a neuron chip, a transceiver and application electronics in your LonWorks. So basically three main components are there in LonWorks. First one is your neuron chip, second is your transceiver and third is your application electronics. So neuron chip is a system on chip software with multiple processors, RAM, ROM and input output interface. So all these things are present on a single chip. Next, it splits device group into intelligent elements which can communicate through a physical communication medium. So in this, the communication take place through physical communication medium. The next one is your Zigbee. So the Zigbee consists of 4-layer physical MAC network application. Physical and MAC layer are defined by IEEE 802.15.4, whereas network and application are defined by Zigbee only. It aims at low cost and low energy devices. Zigbee Alliance is composed of Honeywell, Mitsubishi Invasys, Motorola and Philips. Zigbee we have already discussed also. Then next is your Extend. Extend enables remote control of compliant transmitters and receivers over power lines and electrical wirings present in the house. It is adopted by GE and Philips. The standard defines the procedure for transmission of bits over AC carrier signals. It has low speeds and low data rate. It is mainly used for the control of lighting, appliance network, and security sensors. Now there are two different types of technologies that are used in your home area networks. First one is your Domonet and second one is your Genie. So Domonet uses XML for description and web services for control. It follows a service oriented architecture. It is not tied to any software, language or architecture. A central gateway connects different technologies. So basically in case of Domonet, there is a central gateway which is responsible for connecting to different technology. A tech manager for each technology provide web services for control and access. Next is your Genie. So this technology connects various devices sharing their resources with auto configuration and auto installation. It is based on Java environment and pursued on Sun Microsoft's. It constructs an organized distribution system without any central node. Genie apps use bytecode in order to run on JVM and are portable. It follows object-oriented paradigms. So this technology is basically based on your object-oriented paradigm. Now the two initiatives which are taken in your home area networks are Project Hydra and Amigo. So Project Hydra is a middleware for your embedded intelligent system which connects different service oriented architecture networks. However, your Amigo aimed at ambient intelligence system for your network home systems. Now the connected vehicles. So connected vehicles means the vehicles which are equipped with your sensors and networking and communicating devices. So these are capable of communicating with other devices which are present within the vehicle, communicating with other similar vehicles and communicating with the fixed infrastructure. Now the challenges which are there in connected vehicle is your security, privacy, scalability, reliability, quality of service and lack of global standard. So basically this figure is showing that your connected vehicle is a subset of your vehicular cloud which is further a subset of your IoT. Now vehicle to everything paradigm. So the main component of future intelligent transportation system is your vehicle to everything paradigm. It enables vehicle to wirelessly share a diverse range of information. So information sharing may be with other vehicle, pedestrian or fixed infrastructure is there. It allows traffic management, ensuring on road and off-road safety, mobility for traveling. It follows a distributed architecture where contents are widely distributed over the network. It is not restricted to single source of information provider. It is mainly designed for highly mobile environment and can share information to nodes in vicinity as well as which are placed or located remotely. It has greatly enhanced travel efficiency and as well as safety. The network is mainly used as a tool for sharing and disseminating information. Now, in case of vehicle to everything paradigm, there is a failure of TCP/IP model. So, why there is a failure? So, basically, this TCP/IP model was designed for handling the information exchange between the single pair of entities. So, in case of your TCP/IP model, the exchange of information take place between the sender and receiver. However, in case of your vehicular to everything paradigm, the exchange of information take place between different devices at the same time, and also the information exchange is dependent on the location of the data. So there is particular address, and based on that address the data is sent in case of your TCP/IP model. Further, it can only identify the addresses of endpoint, which alone is not useful for content distribution, and and the increase in number of wireless devices restrict the mobility of nodes if you are going to use TCP/IP model. So now the solution which can remove these issues is your content centric networking. So basically, content centric networking is derived from information centric networking architecture, which more focuses on your data than your actual location. So basically, in case of your TCP/IP, the location of the data is necessary in order to exchange the information. However, here the more than location, it mainly focuses on data. Then the data is hierarchically named. So basically here the addresses are not provided, and the location of data is not given. The identification of data, that where exactly that particular data is present, it is based on the so okay, you know about DNS system, right? So it is similar to that only. So data is hierarchically named. So hierarchical data is transmitted directly instead of being a part of conversation, and it enables scalable and efficient data dissemination. In network, caching allows for low data traffic and works well in high mobile environments. Now, vehicular ad hoc networks. So it is based on dedicated short range communication and wireless access in vehicular environment. Routing protocols which are used in VANETs are derived from MANETs only, that is your mobile ad hoc networks. So high throughput achievable in mobile environment in this case, and they also guarantee low latency in mobile environment. Now the features of VANETs. So high dynamic topology is there, high transmission and computation capability is there, unstable connectivity, large scale predictable mobility pattern. Now the applications. So in case of your safety, for example, emergency braking, lane change warnings, collision detection, or hazard notification, here you can use VANETs. Then for your congestion management, electronic toll collection, parking availability, you can use vehicular ad hoc networks. Then the commercial uses are, for example, your internet access, multimedia stream. And then for providing comforts to the user, you can get weather information, autonomous driving, journey time estimation with the help of your vehicular ad hoc networks. Now CCN, that is your content centric networking for VANETs. First topic is routing. So forwarding and routing based on name of the content, not on the location. Individual content names prefixes are advertised by the router across the networks. This helps to build a forwarding information base for each router. This is similar to the routing table. So with the help of this forwarding information base, you can forward the data. The name of the content remains same and unique globally. No issues of IP address management or address exhaustion is there, because the location is not necessary in this case. There is no issue of IP address management. Communication does not depend upon the speed and direction of the nodes. And the next is your scalability. So an in-network caching mechanism is there at each router. Uniquely identifiable data chunks are stored in content store, which act as your cache. Then subsequent request for data for stored data chunk can be made to CS, that is your content store, and the naming system that is used in CS enables the data to be used multiple times, unlike your normal IP based router. So reduce network load during your increased network size, as a result of which the caching mechanism. Now body and brain architecture is used in your wallets. So basically, this is a 3-layered architecture which consists of your body, nervous system and brain. So basically, body is responsible for sense and execution, nervous system is responsible for the network and transmission purpose, and brain is responsible for taking the decision. So here you can see in your sense and execution layer, there are various sensors, actuators and radio services are there. In case of your network and transmission, various protocols are used in order to transmit the data, or in order to exchange the data between your sense and execution layer and your decision layer. However, in case of your decision layer, some processing is done, and on the basis of that processing, the administrative nodes and the supervisor nodes are able to take the decisions. Now intelligent connected vehicle. Till now we were talking about connected vehicle. So connected vehicles means a vehicle which are interacting with each other through transmission media. Now intelligent connected vehicles mean they have some processing power also, they have the capability to take the decision also. So there are there are 3 phases in your ICB development. First phase is infotainment service with remote information processing. So it is based on your 2G and 3G. Phase 2 is intelligent transportation service, which is based on your 4G LTE and DSRC, and phase 3 is based on your vehicle connected to the cloud. So this figure is showing that your intelligent connected vehicle consists of different components, that is your intelligent transportation, pedestrian communication challenge and transport infrastructure. Now this figure is showing that how intelligent connected vehicles can prevent the crashes and collisions of different vehicles basically. So your intelligent connected vehicles can detect the speed, direction and braking status of other vehicles also, with the help of which you can detect whether the collision can occur or not. And the second figure is showing that here there is a blind spot. So basically this a pedestrian is not able to see your vehicle, and vehicle is not able to see the pedestrian. So if uh, you are using if intelligent this is your intelligent connected vehicle, then this is able to detect that there is a blind spot. So basically intelligent connected vehicle will generate some alert or generate some alarm automatically, which will ask the driver to slow down the speed, or which can also send the alert to the nearby infrastructure which is there in the road. Okay, sure. There is no need to message. If you want to disconnect, you can disconnect directly. Now the VNet. So when there are three main domains in VNet. First one is your in vehicle, second is your ad hoc, and third one is your infrastructure domain. So in vehicle domain composed of one or more board units. So additional presence of advanced driver assistance system is there, such as your camera, proximity sensor, engine sensor, radars, and actuators. And communication is mainly through controller area network, vehicular power line network, and Ethernet. Next one is your ad hoc domain. It is composed of vehicle and roadside units. The vehicle, that is your OBUs in this case, are mobile, and the roadside units are static. The communication mode is either vehicle to vehicle or vehicle to infrastructure. The communication can take place through your DSRC stack, that is your IEEE 802.11. Next is your infrastructure domain. So in case of your infrastructure domain, the RSU connected to the internet by the means of your gateway, and in presence of your RSU, the vehicle may communicate to internet by vehicle to infrastructure interfaces. In the absence of RSU, the vehicle may communicate with each other or to the internet through your cellular network, such as your 3G, 4G, LTE. Now the advantages of your vehicular to everything communication. So first one is your increased traffic safety, second is your increased driver safety, and then optimized time of the travel, efficiency of fuel consumption, secure travel, easier drive in low visibility and unfavorable weather condition is also there. The disadvantages are, okay, 2 minutes, I am getting call from sir. Yeah, we were discussing the disadvantages. So first disadvantage is violation of privacy, the other is loss of data control is there, collection of personal data in case of your vehicular to everything. Then second, use of data is there, data use unauthorized entities also. Then the tracking of movements is there, localization of position. So basically the private data of a person is used in case of your vehicular to everything. Now since we were talking about internet of vehicle, VNets, connected vehicle, intelligent vehicles, so these are these are very similar terms. So there might be a confusion that what exactly is the difference between the all these different terms. So first one is your Internet of Vehicle. So Internet of Vehicle means the integration of vehicle with your Internet of Things. So basically it focus on the integration with your IoT. Next one is your VANET. So it is the specific type of wireless ad hoc network which makes the communication between different vehicles possible, or vehicle to the roadside units. So when it is the network. Next one is your connected vehicle. So connected vehicle means different vehicle which consist of different types of sensor which are able to communicate with each other. So these vehicles are able to communicate with each other with the help of VANET. So the network which is used is VANET, and the vehicles are connected with the help of VANET. Now intelligent vehicle. So if you are going to give some processing parts to a vehicle, then your connected vehicle can become your intelligent vehicle. So basically intelligent vehicle is a subset of your connected vehicle, and the network which is used in order to make the communication possible can be your vehicular ad hoc network, and IOV means the integration of vehicle to your IoT. Now the question. Okay, so before starting question, let's take a break of 2 to 3 minutes, and after that I'll start. I have shared the link. I have already uploaded week 10 PDF into the Google Drive. If someone wants to download, they can access the link. Okay, let's start. So first question is fill in the blank. Facilities that needed to be provided in smart parking lots includes. Option A is identification of empty slots in parking slot. Next is your automatic routing of vehicle to vacant slot. Third is automatic charging for service rendered. Fourth is all of these. I am repeating the question. Facility that need to be provided in smart parking lot includes. First is your identification of empty slots in parking slot, automatic routing of vehicle in vacant slot, automatic charging for service rendered. Fourth is all of these. Anyone?
All of these.
Okay. Okay, I'm resharing the link if anyone wants to download. Yeah, I have shared the link again. You can check the chat box. So the correct option for this is all of these. Next question is, in the near future, auto alert generation in case of sudden heart attack leading to emergency medical condition is supposed to be handled by smart health. True or false? A. Okay, anyone else?
True it is.
True. Yes, true is right. So you can, with the help of smart health, you can send alert auto alert system will be there, which can detect or which can alert the doctor in case of sudden heart attack. Next question is, during an event of disaster, the resource reallocation and service rerouting can be handled by which of the following method? Options are energy monitoring, traffic monitoring, calamity monitoring, health monitoring. C. B. Okay, I'm repeating the question. During an event of disaster, the resource reallocation and service rerouting can be handled by which of the following method? Options are energy monitoring, traffic monitoring, calamity monitoring, health monitoring. I have got two answers, B and C. Anyone else?
C.
C. Yes. See, traffic monitoring means it it will be in the case of vehicular network. So traffic monitoring means it is going to detect the how much traffic is there on the road. So how it can be used in case of disaster. So calamity monitoring is the correct option for this. Next question is, which of the following challenges can be experienced due to the periodic generation of the large volume of data in smart cities? Options are making data volume precise and accurate, provisioning quality of service, proper resource management, none of these. A, C, C. Okay, let's read the question once again. Which of the following challenges can be experienced due to periodic generation of large volume of data in smart cities? Options are making data volume precise and accurate, provisioning quality of service, proper resource management, none of these. So A is the correct option for this because see, we have read this statement in our lecture time also, that if your devices are generating large amount of data, then it becomes difficult to handle that much amount of data and to make the decision more precise and accurate from that much amount of data, because there may be chances that the data may consist of some ambiguous values, there might be some outliers also, so it becomes difficult in that case in order to generate more accurate decision. Next question is, blank enables optimal usages of the huge data generated from different sources and across different platforms. Options are data storage, data cleaning, data fusion, none of these. C, data storage. Data storage is responsible only for storing the data, so it will not enable optimal use of that huge amount of data, right? So data fusion is the correct option for this. Next question is, which of the following is included in mathematical model that is used for performing data fusion? Option is CNN, convolution neural network, statistical model, belief function, all of these. D, all of these. Anyone else who wants to answer?
D.
D. Yes. So correct option is D. So all those three are mathematical model which can be used for data fusion. Next question is, which of the following statements are true about different components present in smart home? So statement 1 is sensor networks and communication network infrastructure. Statement 2 is intelligent control and management. And third is manual instead of automatic access of devices. So A option is statement 1 and 2, B is statement 1 and 3, C is statement 2 and 3, and D is 1, 2, 3 all. A. Anyone else? Which of the following statements are true about different components present in smart home? So statement 1 is saying smart network and communication network infrastructure is there in your smart home. Statement 2 is saying that there is a intelligent control and management. Statement 3 is saying that there is manual instead of your automatic access of devices in your smart homes. So A option is saying that statement 1 and 2 is true, B is saying 1 and 3 is true, C is saying 2 and 3 is true, and D is saying 1, 2, 3 all are true. So I have got 2A. Others also please reply. So in your smart homes there is automatic access of devices, there is no manual access of devices. So A is correct, that is your both statement 1 and 2 is correct, however statement 3 is incorrect. So A is the correct option for this. Next question is, which of the following are included in home area network standards? Statement 1 is saying UPnP and LoanWorks. Statement 2 is saying ZigBee and Extend. Statement 3 is saying DLNA and ZigBee. So, okay. Option A is statement 1 and 2 is true, B is statement 2 and 3, C is 1 and 3, and D is saying all of the 3. So basically there are 6 standards. Check those standards and reply. D. Okay. Others also please reply. If you are not able to recall, go to that slide and check what are the different standards of home area networks. So correct option for this is D. So all these UPnP, LoanWorks, ZigBee, Extend, DLNA, all these are the standards in your home area networks. Next question is, blank provisions amalgamation of different features at home including home automation system, personal media, security system, etc. Options are local area network, personal area network, metropolitan area network, and home area network. This is very clear. Others also please reply. Yes, the correct option for this is D. That is your home area network. Next question is fill in the blank. In vehicle to human and human to vehicle interaction, the human communicating with the vehicle blank is present in another vehicle, is present in the same vehicle, is present outside the vehicle or on the roadside, all of these. D. D. Okay. Vehicle to human and human to vehicle. So in that case, the person should be or the human should be in the same vehicle. First option is first is it should be in another vehicle, second is in the same vehicle, third is on roadside, and fourth is all of these. So the correct option for this is should be it is C is the correct option, because if it is in the same vehicle, then it cannot be possible. Then there is a wait. I need to check this question first, and after that I'll reply to this question. I have some confusion in the option. Please remind me in the next session. I will give you the answer of this question in the next session, because D should be the correct option for this, but I'll check. Next question is information centric networks are derived from content centric network architecture, or is it true or false? True. I'm repeating question. Information centric networks are derived from content centric network architecture. So I'm getting true as an option. Okay. So all are saying true. Okay. Check this slide whether information centric networks are derived from content centric or content centric are derived from information centric. Go check your slides, and after that reply me again. This statement is false, because your content centric network architecture is derived from your information centric. Right, your information centric networks are not derived from your content centric network architecture. So basically this statement is false. Next question is which of the following statements is true about vehicular ad hoc network? Options are routing protocols of MANET, is derived from VANET. High latency is achieved in mobile environment. Does not have wireless access in vehicular environment. None of these. I am repeating the question. Which of the following statement is true about vehicular ad hoc network? Routing protocol of MANET is derived from VANET. High latency is achieved in mobile environment. Does not have wireless access in vehicular environment. None of these. D. None of these. Okay. Others also please reply. No one else? Yes, so D is correct option for this, because VANET is derived, the protocols of VANETs are derived from MANETs. There is low latency in this case, and there is wireless access in your vehicular ad hoc network. So all these three statements which are given there are false. Next question is, which of the following is considered in intelligent connected vehicles? First one is the intelligent transportation, communication channel, pedestrian, all of these. I am repeating the question. Which of the following is considered in intelligent connected vehicles? Options are intelligent transportation, communication channels, pedestrian, all of these. I got only one answer. Others also please reply. All. D, all. Yeah. So D is the correct option. Next question is, dedicated short range communication standards developed by Society of Automated Engineers are SAE Z2735 and Z2945. Is this statement true or false? Anyone for this question? See, all the questions are not covered in your lectures. You have to go through the books also. So some concepts or some questions you will get from your books also. So you have to follow your books. Anyone is saying false? So this statement is true. Next question is, what are the disadvantages of vehicular to everything communication? Options are increased traffic safety, efficient use of fuel, tracking of movement, none of these. C. Okay. Anyone else? What are the disadvantages of V2X communication? Options are increased traffic safety, efficient use of fuel, tracking of movement, none of these.
D.
D. None of these. Tracking of movement is not a disadvantage. See, if your each and every moment is tracked, your personal data is utilized, right? So it is one of the disadvantage of vehicular to everything communication. So C is the correct option for this. Next question is, in LonWorks, each neuron chip has blank memory types. Options are ROM and RAM, RAM and EEPROM, or ROM and EEPROM, ROM, RAM and EEPROM. A. RAM and ROM. Anyone else? In LonWorks, each neuron chip has blank memory types. Options are ROM and RAM, RAM and EEPROM, ROM and EEPROM, ROM, RAM and EEPROM. D. So the correct option for this is D. So all these three types, that is your ROM, RAM and EEPROM is there in your neuron chip. Next question is, V2X follows centralized architecture. Is this statement true or false? B. V2X follows centralized architecture. Statement is true or false? So this statement is basically false because it is based on distributed system or distributed architecture, where different vehicles can interact with each other, vehicles can interact with the roadside units also. So it is based on distributed architecture. Next question is, which of the following is not true about content-centric networking? Options are, it focuses more on actual location than data. Hierarchical data is transmitted directly instead of being part of a conversation. It enables scalable and efficient data dissemination. It is derived from information-centric networking architecture. B. D is correct. Content-centric networking is derived from information-centric networking architecture. Question is, which of the following is not true? First is, it focuses more on actual location than data. Hierarchical data is transmitted directly instead of being a part of conversation. Enables scalable and efficient data dissemination. And fourth is your derived from information centric networking architecture. A. Okay, what is the A? Focuses more on actual location than data. Yeah, so the correct option for this is A, because in content centric networking it focuses more on data than on actual location. So A is the correct option for this. Next question is, in VANET, link durations are long and easily scaled up to include all the vehicles on the road. True or false? In VANETs, link durations are long and easily scaled up to include all the vehicles on the road. Is this statement true or false? B. False. Anyone else? Okay, so do you okay, what is the feature of your minutes? The links are intermittent or long lasting? No one. Okay, so basically the rules or protocols are derived in VANETs are derived from MANETs only, or the features of VANET is also similar to MANETs only. Only the mobility factor is added in case of VANET. So the links which are there between different devices are intermittent. Basically, these are not long lasting. So this statement is false. Next question is, which of the following is not true about ad hoc domain? Options are composed of vehicles, that is your OBUs, and roadside units. Vehicles and roadside units are mobile. Communication take place through DSRC stack. Communication mode may be either V2V or V2I. Anyone?
C.
C. That is communication take. Question is, which of the following is not true about ad hoc domain of your V2X paradigm? So in that case, communication take place through your DSRC stack only. So this statement is true. Which of the following is not true? So the correct option for this is B. B is vehicle and roadside units are mobile. However, in case of your ad hoc domain, vehicles are mobile, whereas your roadside units are stationary. So B is not true about your ad hoc domain. Next question is, in infrastructure domain, RSUs are connected to internet by means of blank V2I interface, cellular network, V2V interface, gateway.
D.
D, gateway. Okay. Anyone else? D. Yeah, so correct option for this is D. Next question is, which of the following is the draft standard for wireless access in vehicular network, vehicular environment, that is a wave? So options are IEEE PI 609.0, IEEE PI 609.1, IEEE PI 609.2, IEEE PI 609.3. Anyone? I'm repeating the question. Which of the following is the draft standard for wave? Options are IEEE PI 609.0, IEEE PI 609.1, IEEE PI 609.2, IEEE PI 609.3. A. So correct option is A, that is your IEEE PI 609.0. Next question is, inferences drawn from multiple sensor type data is qualitatively superior to single sensor data type data. Options are true or false. So the data which you have taken from multiple sensors is more superior as compared to single. Anyone? A. Okay. Anyone else?
A.
A. Fine. Others also please reply. The data which you take from multiple sensors, is that data more superior to the data which is taken from single sensor? Yes or no? So this statement is true. Next question is, which of the following statements are not correct regarding data fusion? Options are rich in information, generate better intelligence, optimal amalgamation of data is there, expose critical data sources and semantics. Anyone?
D.
C. Okay. Anyone else? Yeah. So D is the correct option for this. Next question is, what happens at signal level of data fusion? Options are fusion of information at the imaging device level itself, fusion of information at sensor node within the local network itself, fusion of information prior to decision making, ensemble of decisions. What is signal level of data fusion?
B.
B. Fusion of information at sensor node with the local area, local network itself. Yeah, so this statement is correct. So B is the correct option for question number 25th. Next question is, which of the following is not a functional layer of smart parking? Options are information collection, information fusion, system deployment, service dissemination.
B.
D. Service dissemination. Okay. Anyone else?
B. 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 It is.
B. Information fusion. Okay. Others also please reply. B. Okay. Yeah. So B is the correct option. Next question is, solution related to smart cities should have blank, cognitive management framework, low power transceiver, predictive model for energy consumption, all of the above. D. Anyone else?
D.
D. Fine. D is the correct option. Next question is, UPnP device search and advertisements are blank through HTTP over UDP over port number 1900. Options are multicast, unicast, broadcast, store. layer technology. Options are data link layer, application layer, network layer, transport layer. B. B is application layer. Okay, yeah. So application layer is the correct option for this question. Next question is, in LearnWorks, every device includes a neuron chip. Is this statement true or false? A. True. Anyone else? In LearnWorks, every device includes a neuron chip.
A. A.
A. Yeah. So this statement is true. So these were the questions of week 10. I'm again sharing the link of Google Drive. If you want to download the PDF, you can access this link. And please also follow the books, because you will get some questions from the book also. If you want me to discuss any topic, and or if you have any query that you want me to take in the next session, you can discuss now. No? If not, then I'll terminate the session. Okay, then I'm terminating the session. Then we'll meet on next Friday again. Okay, thank you.